can see there's an apple trees that's sitting down here. This fellow is Isaac Newton. If you guys know who Newton is, right? The one that make you guys struggle a lot in physics, okay? So that's Mr. Isaac Newton. So this makes Mr. Isaac Newton is the one that actually realized, everything on Earth, it's being pulled by something known as gravity. So Mr. Isaac will be like, oh, one day there's apple drop on his head while he's reading. He'll be like, wait, how come the apple come down and the apple don't goes up? I mean, if it's for me, I'll just eat the apple, but that fellow doesn't eat the apple. The fellow take the apple and see. Why this apple drop? Oh, so he realized everything on Earth gonna fall towards the Earth. Why leh? Then they discovered there's a thing we call gravitational force. All right, so that is given by Isaac Newton, gravitational force. So yeah, so this idea about gravitational force. And this gravitational force, when there's a free fall, there will be a gravitational acceleration. Last week we learned free fall, yeah? Okay, so the gravitational field strength here is actually 10 Newton per kg. But in your syllabus, they changed the 10 into 9.8. It could be also 9.8 meters per second square. This is gravity acceleration. Okay, that's gravity acceleration. So in this situation, we need to understand there's something we call weight. So last time you guys learned mass and weight, they're actually the same thing. So what is weight? What is mass? Okay, listen carefully. So all of you today are standing on the earth. So this you standing on the earth. Guys, I want to ask a simple thing. Today, if you stand on earth, right, there will be a force pulling by the gravity, correct or not? So you will being pulled by gravity. So I write force of gravity over here. So when you're being pulled, is this object or this human, is it going down the earth? He's not going down the earth. Whereas his feet will be pushing the ground. If you guys don't believe, right, now everyone is sitting down, isn't it? So you guys lift your leg upward, like your leg doesn't touch the floor. And you guys will find that your ass is actually pushing the chair, right? We guys try that. You lift your leg upwards, you feel that your ass is actually pushing the chair. But the problem is, are you the one pushing the chair? No, you did not apply force to push the chair, but it just happens naturally. You get what I mean? Because there's a force of gravity that pulling you downwards. And that force that pushing naturally is because of your mass of your body. So the more heavier you are, the more force you push down the ground. So that force, we have a name which we call as weight. Can you guys understand me? All right. Another thing that you guys step on the floor, when you guys step, right, you guys don't push the floor one. But when the moment you step, right, the gravity is pulling on you. So literally you are applying force on the floor. So that amount of force is what they known as weight. Can? So this weight will be depending on your gravity. So how do we calculate weight? It's actually very simple. We will have a formula. Weight equals to mass multiply gravity. So gravity is 9.8 meters per second square. Mass is in kg. Weight is in Newton. So this is the formula of weight. Okay, you guys can please write it down. Hi, Warren. Which school are you from, Warren?
Oxford. Same school.
Okay, cool. All right, so this is the idea about what is weight and what is mass. Then we're going to look into free fall. Now, free fall, actually, we learned it last week. So free fall means it's only under the influence of gravity only. Okay, now here we're going to talk about the difference between mass and weight. So guys, the difference between mass and weight, in terms of quantity, guys, we learned two quantity before. In chapter number 1, we learned vector quantity. And we also learned about scalar quantity. So, can you guys recall what is the difference between vector and scalar? Aiden?
I forgot.
Wow, you're very honest on that fella. Jingwei, what about you?
I forgot also.
You've very honest. Xingxuan,
Not really sure.
Erica. Erica, you can? Magnitude and directions for vector. Very good. Thank you so much. Shreya, I saw you raise your hand. Yeah, also thank you. So vector means the quantity giving you magnitude, means there's a size of the quantity and giving you direction. I give you an example like force, pulling force. When I mention pulling, right, you know you pull. Pull have direction and you have size of the force. Can you guys understand? That's a vector quantity. Where for scalar quantity means only magnitude. It will only be able to tell you the size. For example, your mass. When I mention 30 kg, does 30 kg tell you the direction or not? No, right? 30 kg just tell you the size. So you only know the size. So there's a difference between them. So in this case, when I mention weight, right, you will instantly and straight away, you know, weight is acting towards the center of gravity. So weight immediately tells you direction. When I say weight, would you think about the weight going upwards? No, right? It's always the downward force, isn't it? So weight here, it has direction. So it must be a vector quantity. But for mass, you don't have direction. You only have the size of the mass. So it is a scalar quantity. Okay. Then both of them, weight is measured in Newton. Mass is in kilogram. And then the difference between them also, weight changes according to gravity. Because the stronger the gravity pull on you, right, the larger force you apply on the ground. Can you guys understand me or not? But if you're on the moon has weaker gravity, the force push on the moon is lesser. Okay, so it changes according to gravity. What about the mass? Do you think it will change or not? Like the mass on Earth and the mass on moon, they are the same. No matter now today, Aiden, let's say you are 80 kg. So if Aiden is 80 kg on Earth, he's going to be 80 kg on moon. He's going to be 80 kg on Mars. He's going to be 80 kg maybe in someone's heart. So your mass never change. All right. Only weight changes according to gravity. So mass is always constant. Of course, you don't say that, teacher, what if I diet leh? Brother, if you diet, then different story already lor, correct or not? Now we are talking about in different position, okay? In different position. So it's always constant no matter where you go. And how we measure mass, since it's a kilogram, we use a weighing balance. For weight, we use a Newton force meter, Newton meter. Newton meter looks something like this one. There's a reading over here, and they hook. So let's say you want to hang something here to read the load, then there will be a reading here. So this is a Newton force meter.